So first of all, thank you so much for the invitation to be here today. This is quite an honor. And it's also, for me, it was a challenge to think about what I was going to talk to this audience about. And one of the things that I think is so amazing is that, you know, over the 9 years that I've been working on this, and many of us have been working on this, we have developed an amazing community of practice. And I think that's one of our big wins, which never even makes it on a slideshow, typically, right? And so being part of this community of practice has been a highlight of my career, and I'm honored to be here today. And I know we're missing some of our colleagues, right? It's not the whole community here, but it's been wonderful to work with federal partners, state partners, nonprofits, other governments, right? Because some of us in the room had the opportunity to work with the Commission on Environmental Cooperation on their blue carbon effort as well. So what an amazing opportunity and what a ride it's been so far, right? So Tana Marie gave me quite the task to try to cover in a keynote. But the main message I want you all to take home today is, wow, look at all this cool stuff we have done together. This is amazing. But also, hey, we're not done. There's still lots of stuff we can be doing. We'll get to that at the end. But so the three things I'm trying to cover, which I am clearly not going to be able to do justice fully to, are where are we at with the state of science, policy and management connections and opportunities, and then some big picture thoughts on where we might be headed next. And what you're going to get is sort of my view of all of this, and I cannot wait to hear all the presentations today, where I know many of us are going to join in this conversation and share where we've gotten to. I'm thrilled to be here to be part of that conversation. Okay, so let's go. Science, where are we at? So some of us in the room were part of the NASA Coastal Wetland Carbon Grant that was led by Lisa Wyndham-Myers at USGS. And in this project, we were looking at sites around the US, circled here in red, and really trying to better understand the soil carbon in these wetland sites and how we could potentially be using remotely sensed data to get at some of that. And I don't expect you to read this list, but this project was very, very fruitful and led to a lot of different publications as well as some really cool data sets. I'm going to just highlight one right here that I got to be a part of. This is a publication led by James Holmquist. James, I know you're here. Raise your hand. There's James. And so this was about uncertainty in the United States coastal wetland greenhouse gas inventorying process. And this is specifically about, as we worked to include coastal wetlands in our US greenhouse gas inventory, what did we figure out? And one of the things I think is really useful about this publication is that it actually points us to what we don't know and where we should be focusing additional research effort so that we can get better at understanding these systems and at including them in our inventory process. So what you see here on the x-axis here is the effect of uncertainty on total flux. And this is total greenhouse gas flux. And so the main take home here I want you to walk away with is, so if you look at these top four, they're all, you know, roughly the same amount of uncertainty, and then it really drops off, and we're clearly more certain about these other factors. So 2 of these 4 are about methane. We need to better understand how methane fluxes work in freshwater systems and also in our saltwater influence systems. And then another main area of uncertainty is the depth loss to erosion. So what this means is what happens as we have sea level rise and we are starting to have that front end of the marsh eroding, in some places rapidly, in other places less rapidly. What happens to that carbon though? How far is the depth affected, and what happens to that carbon? Does it immediately get blown off and mineralized, or does some of it stay buried in the sediment? We really have a lot of uncertainty here, which affects our ability to do our inventorying process and to figure out how much we should be saying we're having greenhouse gas fluxes from that loss of wetlands. So here are, you know, sneak peek at my end slides on where we need to be working. Here's some examples of where we need to be working. Now, interestingly, we have started to fill some of these gaps. There's more information. This is Omar Abdul Aziz et al. Publication, so many of you here in the room, from 2018 about the work that was just being described here in Waquoit Bay. And what's really interesting is here the results were suggesting that it isn't driven as much by the nutrient influxes as we had originally hypothesized you might have a bigger impact of that nitrogen and phosphorus input on greenhouse gas fluxes. Instead, they found that soil temperature was a key factor in predicting those fluxes. So here we're starting to have a better understanding of what are those controls on methane fluxes. What do we need to be paying attention to? So this is great. Another methane paper that is super relevant and I think a game changer as we think about blue carbon in the future. Again, Kevin Kroeger, another person in the room here, and coming out of this team, of course, is looking at these tidally restricted areas, of which we have tons in the US and in most developed countries, right? Because as you put in things like railroad tracks and roads and bridges, you end up putting in culverts, which narrow the amount of tidally exchanged water. So you have what used to be fully salt water, or largely saltwater influence, suddenly freshening. And as you freshen, then you affect that greenhouse gas flux a great deal, and you get a lot more methane off these systems. So this is really exciting work suggesting we have potentially some very low-hanging fruit here for restoration opportunities that might have really significant greenhouse gas impacts if we could basically resalt those systems that have freshened. Okay, so here's a paper I was a part of. So I mentioned we have successfully included coastal wetlands in our greenhouse gas inventory. I will talk about that a little bit more when I get to the policy section. But this paper came out in Nature Climate Change last fall and described what we learned from the process of including coastal wetlands in our greenhouse gas inventory. And so our main findings were that US coastal wetlands are a sink for greenhouse gases for sure. However, the loss of wetlands is a growing source of greenhouse gases, and most of that loss is in the Gulf, but not entirely. Now, interestingly, we actually as a country do not have a good way of tracking how much and where all of our restoration is occurring. So when we tried to do that at a national level, it was very challenging. But what we were able to come up with is that there is a lot less restoration occurring than loss. So there are some opportunities here to potentially try to offset more of that loss with more restoration. Of course, what we need is some funding to do that. But there's a big opportunity there. The last point I want to make, and I'll come back to this, is that we here in the US accomplished this using globally available Landsat data and then the Wetlands Supplement, which came from the Intergovernmental Panel on Climate Change. And so this suggests that even though we are considered a very data-rich and science-rich country, the methods we used could be duplicated by other countries. This globally available Landsat data is available to anyone around the world. And this is important, and I'll come back to this in the policy section, because we were one of the few countries to include coastal wetlands in our inventory by 2017, as the IPCC had requested we try to do. And what we didn't want to do was do it and then have everybody say, well, but that's the US. Of course you guys can do it because you're data rich and you have a lot of science and it's science investment. Yeah, all of that is true. But we wanted to make sure that the point was made that we did it in a way that other countries could do it too, without necessarily having to be the data and science powerhouse that we are here in the US. And I'll come back to that a little bit. Here's Brian Needleman et al.'s paper. Again, a bunch of you in the room helped with this. This is really important because it lays out all the science considerations that went into getting our verified carbon standard methodology for wetland restoration around the world. So big achievement there. This is an interesting paper. I wanted to throw this one in. And I think this is really interesting because they focused on what could we be doing to better manage the systems that are already there. So instead of thinking about the restoration side of things, what could we be doing with the habitats that still exist to potentially help them sequester more blue carbon? And so suggestions here are about limiting nutrient inputs, possibly restoring hydrology, possibly trying to get your top-down control by reestablishing your food web and your bioturbators better. So I thought that was a really interesting contribution as we think more about what all can we be doing, what's the science we need to be better managing these systems. Now this one I wouldn't bin as just a blue carbon publication, but I think it has massive implications for blue carbon, which is why I wanted to bring it up. This is a publication by Enright et al., and my colleague Michael Osland was a co-author on this. So in this paper, they looked at what is happening as we have sea level rise, and in places where the marsh maybe isn't keeping up with that sea level rise, but maybe can move inland, what does that look like? And so this was a publication that focused on the Gulf. When you see these hot pink areas, it's showing where we have current coastal wetlands. And then the pink, the lighter pink, is where we could have coastal wetlands as we get a little bit of sea level rise. And so this is sort of your ideal situation where there's nothing blocking that wetland from slowly moving inland as we get sea level rise. So you have that inland migration that's possible. Now, then there's 3 examples of where that isn't possible. And the first of those is that there's some kind of natural geologic topographic feature, you know, like an escarpment, that makes it impossible for that wetland to move. And so here's an example of that happening in the Gulf, where as sea level rises, those wetlands can only move the tiniest bit inland. And then after that, if they can't keep pace, they will drown, and we will lose a bunch of that coastal wetland. Here are the 2 pieces I'm most interested in, though. So here's where a wetland is being blocked by urbanization, and here's where a wetland is being blocked by another human structure like a berm or a dike, right? And so these are cases where we could have a lot more inland migration, except for the fact that we can't because of human structures. And so you're seeing that here where there's just the tiniest bit of pale pink, so it looks a lot like this one, but it's not due to the geology and the topography, it's due to human settlement. So the reason this matters is they then took this analysis for the entire Gulf, and these are just different levels of sea level rise. How much inland migration might you have? And what I want you to take away from this is where you see the darkest blue is where you have the most ability for inland migration, right? So this is where the topography is fairly flat, and these wetlands are going to likely have the ability to move inland. But pair that with what they did here was look at major places where future urbanization is planned. Okay, and you're seeing places around Houston, and of course in Louisiana around New Orleans, places in Florida like Tampa. And what you find is that in some of these cases, there is a huge, tremendous amount of possibility for inland migration because these are fairly flat areas, but that will be blocked by urbanization if we don't do something about it right now. So I think this is tremendously important to be thinking about in the blue carbon community because we are going to lose the opportunity to get those climate mitigation benefits and all those other wonderful co-benefits that were mentioned if we don't take policy action right now to think about what is planned land use in the future and make changes right now to make sure we can do that inland migration in the future. All right, and then the last thing I want to mention in the science focus piece is the NSF-funded Coastal Carbon Research Coordination Network. So this is a research coordination network, an RCN, funded by NSF. Super exciting. Again, James is leading this. Raise your hand again, James. With Pat McGonigal. So talk more to him today if you get a chance. I don't know that you're going to get a chance to talk about this. So if not, make sure you seek out James. I think this is super exciting. The whole goal of this RCN is to accelerate the pace of discovery in coastal carbon science by serving up data and tools and synthesis opportunities. So if that excites you, go talk to James, find out more. They're definitely looking for data sets to become part of their network. The more we can combine data sets, the more power we have to do the kind of analysis we need to figure out what's controlling these different carbon processes in these systems across the country, right? So super exciting that they have that NSF funding. Okay, I'm going to shift gears, and as I said, I know that was just a smattering. I hope I didn't insult anybody by not listing your favorite paper. But that's just the last couple of years of really exciting stuff moving in the science world. Now moving to the policy and management progress. It is super cool that we have included coastal wetlands in the voluntary carbon market through getting the verified carbon standard method totally established by November of 2015. This allows you to get carbon credits for coastal wetland restoration anywhere in the world. And when we say coastal wetlands, we're including seagrasses, salt marsh, and mangroves. So this is phenomenal because every other methodology that's out there or that had come out before this one was limited in geographic scope or to a specific kind of wetland. So this was the first one to do it all anywhere in the world. Super exciting. I had hoped that by today I might be able to say that the methodology for carbon credits for protecting a threatened wetland would also be out. I've been hoping that a while though. So it's still in process. It's getting reviewed. It will come through, I am sure. It's very exciting that we have this one too in the works, right? So you don't have to have your wetland get degraded and then you have to restore it to get the carbon credits. You can protect it if it's threatened in advance and then get the carbon credits for the avoided emissions that are not going to happen because there was that threat and you stopped it. So that is super exciting. And stay tuned. That's all I can really say on that. Many of you may know that a lot of my work when I was at NOAA was really thinking about blue carbon at the national level. And in the previous administration, there was really a growing interest in using natural ecosystems as part of our climate tools, right? And so it was pretty exciting. I actually had a hand in making sure that President Obama's priority agenda for enhancing the climate resilience of America's natural resources actually did include a whole mention of conserving ecosystems that store carbon. And not only did we get that in there, we made sure it didn't just say forests, which is where everybody wanted to go first, of course. And we said, yes, and grasslands and wetlands and other ecosystems as well. One of the actions in this was to actually tell NOAA, you will fund this thing called the U.S. Coastal Wetland Carbon Work Group, which NOAA then did. And so this was NOAA and Restore America's Estuaries and EPA led. And the whole goal of this was to use that wetland supplement I talked about that was the guidance from the Intergovernmental Panel on Climate Change that came out in 2013. We said, okay, we're going to do a minimum of a Tier 1 assessment. That's the most basic assessment you can do of your greenhouse gas fluxes. And then we also wanted to make sure we were identifying research gaps and needs. And we were doing this using NOAA's Coastal Change Analysis Program, or CCAP data, which is based on that Lancet data that I mentioned. And then we were using, obviously, experts and the scientific literature and that wetland supplement. So it's really exciting that then in 2017, the US was among the first and only a few countries in the world to include coastal wetlands in our greenhouse gas inventory. And the cool thing is that unless we literally stop doing our greenhouse gas inventory, and I actually hesitate to mention that out loud in case there's anybody in the administration ever listening, but it's unlikely that we will stop doing that. Unless we do that, we now have coastal wetlands in our baseline, and we cannot take them out. So we will continue to need to update this and to think about where are we losing these wetlands, where are we restoring these wetlands, and how does that affect our greenhouse gas balance. So in my opinion, this is a huge policy win that has long-term implications for how the US will think about and track our coastal wetlands. Now, that said, as I mentioned in our Nature Climate Change paper, we talk about the ways we can improve that. We are not doing a perfect job. There's lots of things we could do to do an even better job, but it's fabulous that they're in there and they aren't going anywhere. And then the other thing that's really kind of cool is that what's come out most recently from the Intergovernmental Panel on Climate Change in their 2019 refinements, it's a little complicated in that they didn't choose to put out any specific new guidance altogether. Instead, what they've said is, please continue to use the 2006 guidance and the wetland supplement as you do your greenhouse gas inventories. But it's great that they are specifically saying to countries, you should be using this. So again, that's a win because we're not formally required to put wetlands in our inventories. And now we are not yet required, but it's still recommended that we do that, and I hope we're moving towards requiring it. Okay, so at the same time, there's this growing interest in thinking about natural climate solutions for the US. So this is another paper that came out last fall that I'm one of the bajillion co-authors on. And this was really saying, okay, so if we use all of our natural ecosystems in the US, how much of our greenhouse gas fluxes can we offset? So the take home here, a couple of them. First, up here we have three categories. So forests, and then grasslands, and managed lands, and then wetlands. So it's awesome that wetlands made it into this. This is where I helped out. Now you may notice that our wetland bars are a lot smaller than these other bars. This is mostly being driven by the fact that even though we do have extensive coastlines in the US, we have a lot more interior land. So we have a lot more grasslands and forests where we can be doing management activities. It also, however, is an indication that we have done a better job in this country of managing our coastal wetlands than other countries. We have lost fewer of them. We have still lost a bunch, don't get me wrong, but we have lost fewer of them than other places, and we are losing fewer of them than other places. And I'll show you that in just a second. But it's really exciting that wetlands are a piece of this strategy. Just to give you a sense of what some of these things look like, this says reforestation. We can do different natural forest management to sequester more carbon. We can have avoided forest conversion or urban reforestation. Those are examples from the forest section. In the ag lands, we can have avoided grassland conversion. We can do cover crops and alley cropping. So they investigated a whole bunch of different topics. For the wetlands, we were looking primarily at tidal wetland restoration, which we're talking about here, peatland restoration, and then avoided seagrass loss and seagrass restoration. So that's nice, this 1.2 petagrams. What does that mean, right? I mean, who knows? Huge number. Okay, well, here's what it really means, is that just over 20% of our US net emissions every year could be taken up if we implemented all of these practices right away. And what I think is really important to recognize about that is, one, I was pretty impressed that it was as high as 21%. Although I had some friends who were like, what? Why can't those plants do more? And I was like, are you kidding? We're talking about millions of years of old carbon, and we're asking them to take that all up? No, thank you. It's not going to happen. 21% approximately. That's awesome. It clearly makes the case that we still have to be reducing emissions, because we cannot get there with all of these practices implemented. We also aren't doing all of this. This administration not particularly excited about this stuff right now. I am hopeful that in a couple of years we will be implementing more of these practices. But it is a sizable fraction that can come from technology, if you will, that we already have, because this is photosynthesis, right? That's what we're talking about. CO2 taken out of the atmosphere by plants. That's the technology we have. We know it works. We just have to implement these practices to allow plants to do more of it, right? So super exciting. We don't need any new technology. We just need to implement all of these practices. Okay, so I mentioned that I'd show you the global analysis. I just wanted you to see that when a very similar analysis was done for the globe, the wetland piece is slightly larger than it was in the US. This is sort of a double-edged sword, if you will. Like, yay, I'm glad there's a role for coastal wetlands, but actually what this means is that there's more restoration that can happen and there's more avoided impacts, which simply means that there's been more or continue to be more impacts to coastal wetlands in other places. But coastal wetlands are definitely a piece of these natural climate solutions, which is very exciting. Okay, and then I'll just mention there are additional national analyses underway. I already know about the one in China, India, and Canada, and there may be more, so this is very exciting. When we talk about management, I think it's super exciting that we're at the point where there are blue carbon projects finally coming online. So we have here at the Virginia Coastal Reserve, they have restored about 9,200 acres of eelgrass since 2009, and they're currently trying to link to carbon markets to be able to support more restoration. And then, of course, there's our very own Herring River tidal marsh restoration here, where the greenhouse gas benefits of that restoration are a piece of the discussion and the design of the project. So very exciting. I would love to see more of this, more on-the-ground projects that are happening, and I think that's part of the next steps. So I am wrapping up. Next steps, I've got 3 of them. First, for this community, keep doing the awesome policy-relevant science you're doing, right? This is super important, and I can't understate how important this is for supporting the policy and management opportunities. So one of the places I think we need more work is on microalgae in this paper that Jen and Stephanie and I are co-authors on. We did investigate the role of kelp, but the role of kelp and seaweed continues to come up, and you see it in the literature. And what I am not clear on is where the human management component in this system is so that we could increase the amount of carbon sequestered beyond the baseline. So we need more research here. Methane, I've mentioned it already, but better understanding methane will help us in multiple policy fronts. So any work on methane will be very relevant and helpful. We need to better understand what happens to carbon in those drowning wetlands, or in salt marshes invaded by mangroves, or in salt marshes or mangroves or seagrasses experiencing other global change. We need to understand what's happening to that carbon under all of those different threats so that we can better do our inventory and other policy and management decisions. We also need to better figure out how to track restoration projects and the effectiveness of that restoration. So not just acres done, but is it really working? How are they functioning? What are the carbon dynamics like in those restored systems, right? So keep doing the amazing science. Okay, next step number 2. Also, continue to spread the word about these blue carbon benefits, because a lot of people still don't know that coastal wetlands play a role in these natural climate solutions. But I was super excited on Friday to see this come out. Australia has announced that they are going to fund a scientific hub to protect ocean carbon ecosystems, and they want this focused on the Pacific. And part of what they're talking about is bringing young scientists in to have a place to all work together on this stuff. How exciting, right? The word is getting out there, and this is amazing. This is what our 9 years means, right? This is great. But keep talking about it, because there's still a lot of people who don't know, and we gotta spread the word. All right. Also continue to think outside the box. What's possible? How can we innovate here? So one of the things I had a student work on was blue carbon projects around the world, and one of the main things that came out of that work was that there was a really tight connection between blue carbon opportunities and people's lives and livelihoods. How can we do a better job, particularly here in the US or in North America, thinking about how we can find new champions and more opportunities by connecting to people's lives and livelihoods with this, right? It's not some esoteric, awesome science and interesting policy thing. This needs to connect to people's everyday lives in whatever way we can. Where can we reduce sources or increase sinks at the least cost? So we're looking for that bang for our buck. How can we do coastal restoration at a larger scale without costs getting out of control? This is where we really need some innovation. Where are there additional partnerships we could be developing so we could do more together? And how can we either increase the price of carbon or figure out that whole carbon money situation so that we can make doing more coastal restoration more viable? Scott, no pressure, but I'm hoping you have answers to this later, right? He's going to have it all. Scott's got this. No, this is someplace we all need to be working. There's huge innovation that we need to be doing here. So with that, I want to say keep up the good work. Coastal wetlands and communities everywhere are depending on us. I am thrilled to be part of this community. And I want to thank you. Here's my email address and my website if you want more. And then one last plug. I am in a career transition right now. So if anybody has ideas, I would love to hear your thoughts on opportunities arising where this kind of work will be relevant and useful. So thank you so much, and I'm happy to take questions. I'm happy to take questions.
What we're going to do is we're going to take 2 questions now for Ariana, and then we have a little bit of an extended Q&A session time after we have some more science presentations that we'll invite Ariana to be a part of that. Any takers for questions for Ariana? Do you guys need more coffee?
I was wondering. Maybe we need more coffee.
Any questions? It's always the warming up period. You don't want to be the first one, but it's okay. Here we go. Thank you.
Yeah. So the National Academy of Sciences actually ran a series of workshops and then recently came out with a report. And NOAA and EPA actually funded a piece of that to make sure that coastal wetlands were a part of that discussion on CO2 reduction. But part of what was looked at was sequestration underground and other technologies. To be honest, I don't know what the number was if they came up with a specific, like, this is what we can do. My understanding is that those technologies are so far proven, but only at very small scales, and that the scaling up piece is the really hard part. And so we aren't there yet. Now, I'm hoping that in the next decade, we will be getting to a point where we have more of that technology that can be used at scale, at power plants, and to really be doing this massive reduction. But that was part of the reason for doing the analysis of the natural climate solutions piece, was to say, hey, folks, we don't need new technology at this point. We just need to implement all these best practices that we already know we can do. You mentioned it's free. It's free in the sense that the plants can do this, but putting in alley cropping or a row crop, right, where you put in plant trees between your fields and sequester more carbon in the trees then, or doing those forest management practices and reforestation, or doing coastal restoration. Unfortunately, none of that is free. Otherwise, I think we'd all be out there like doing it right now, right? Mm-hmm. So there is a cost to that, but it's a technology we already have. We don't have to wait a decade or two for it to come into fruition. And if we were reducing our emissions at the same time through more renewables and being more energy efficient, et cetera, then that 20% that's the natural piece starts to rise in proportion, right? So that's where I find hope in all of this, even though on some days it does feel kind of bleak. But I think there is still a lot of hope and opportunity, and I'm very much hoping that with a new administration, perhaps, we can actually start to get more of this off the ground immediately.